Hey guys, Mr. Backerberg here. In this video, we're going to look at simplifying square roots. Sometimes when we're working with square roots, the numbers that we're dealing with are nice perfect squares. So for example, the square root of 25. 25 is a nice perfect square, so when we square root it, we get a nice whole number answer. So the square root of 25 is 5. But not every number is a nice perfect square, so we need an alternative strategy as to how we're going to approach those. So for example, if we wanted to look at the square root of 45. 45 is not a nice perfect square, so we can't just figure out one numerical answer for it using our traditional perfect squares. So what we're going to do instead is we're going to make a factor tree, and we're going to look for pairs of numbers as we're factoring this out. So we want to think about numbers that when you multiply them together, we get 45 as an answer. So one way to get 45 would be doing 5 times 9. 5 can't be broken down any further. 5 is prime. 9 can be broken down. 9 is 3 times 3. And then these 3's cannot be broken down any further. So we made our factor tree and we broke the numbers down as much as possible. Now we're looking for the pairs of numbers. So right here, I see that we've got a pair of 3's. As we're simplifying down this radical, what we're going to do with those paired numbers, we have a pair of 3's, so we're going to take the 3 and we're going to put it out in front of our square root. Now, underneath the radical is going to be any leftover numbers that we didn't pair off. So 5 didn't have a pair, so the 5 is going to stay underneath the radical. So we can simplify down the square root of 45 into being 3 times the square root of 5. Now we're going to do a lot more examples here. So in this first one, we're looking at the square root of 12. So again, we're going to make our factor tree, and we're going to look for pairs of numbers inside of the 12. So 12 could be 3 times 4. 3 can't be broken down any further, but 4 can. 4 is 2 times 2. Now 2 cannot be broken down any further. So we made our factor tree and we broke down 12 as much as possible. Now we're looking for pairs of numbers. So I see right here that we've got a pair of 2's. So we take the 2 out of the radical. 3 didn't have a pair, so it stays underneath the radical. So the square root of 12 turns into 2 times the square root of 3. Now for our next one, we've got the square root of 40. So again, we're going to look at making a factor tree. 40 could be 4 times 10. 4 can be broken down into 2 times 2. And 10 can be broken down into 2 times 5. Now we're looking for pairs of numbers. So right here, I see a pair of 2's. So we take a 2 out of the radical. Underneath the radical is anything that doesn't have a pair. Now this last 2 does not have a pair, so it stays underneath the radical. And this 5 doesn't have a pair, so it also stays underneath the radical. Now, if you have multiple numbers that get left over underneath the radical, we need to multiply those back together. So that 2 is still going to stay out in front, but if we take the 2 times the 5 underneath the radical, that's going to turn into a 10. So the square root of 40 simplifies down into 2 times the square root of 10. Now looking at this one, we've got the square root of 121. So if we look at making our factor tree here, looking for numbers that when we multiply them together, in order to get 121, the only way to do that is with 11 times 11. Now 11 is prime, so that can't be broken down any further. Now what we've got here is we're looking for pairs of numbers. So right here I see that we've got a pair of 11's. So we take the 11 and we put it out in front of the radical. Now underneath the radical, we look for something that is left over. And if we look, there's nothing left over. So what that tells me is that this radical is no longer necessary to have there. Now 121 is actually a perfect square. Maybe we didn't recognize it right away, but it is. The square root of 121 just turns into 11. For our next one, we're going to look at the square root of 48. So again, we're looking to break this down using multiplication. So we could do 4 times 12. 4 breaks down into 2 times 2. 12 breaks down into 4 times 3. And this 4 breaks down into 2 times 2. This 3 does not break down any further. So we're looking for pairs of numbers. Right here, I see a pair of 2's, so we take the 2 out of the radical. But I also see that we have another pair of 2's down here. So I need to take another 2 out of the radical. When you take out more than one number, we want to multiply those numbers together. Now, if I look, this 3 doesn't have a pair, so that 3 stays underneath the radical. Now, if we multiply these 2's together out in front, 2 times 2 is 4, and we're not changing that root 3 at all. So the square root of 48 simplifies down into 4 root 3. Now, for our last one, we're looking at the negative square root of 72. So we're going to focus on the 72 first and make our factor tree. 72 is 8 times 9. 8 can be broken down into 4 times 2. The 4 breaks down into 2 times 2. This 9 is going to break down into 3 times 3. And once again, we're looking for pairs of numbers, but we have to be careful because there is this negative out in the very front. So I'm going to put the negative down. Right here, I see that we have a pair of 2's, so I'm going to take that out of the radical. Over here, I see that we also have a pair of 3's, so I'm going to take that out of the radical, and we're going to have to multiply these together. Now, I've got this other 2 that didn't get paired off with anything, so it's going to stay underneath the radical. Now, if I do the multiplying out in front, we've got negative 2 times 3, so that's going to be negative 6, and we're going to leave that square root of 2 on the end. So the negative square root of 72 simplifies down into negative 6 root 2. Now, if we take a look at this one, we've got 3 square root of 50, and we're going to look at breaking this down. So it's going to be very similar. The only difference is now we have this extra number out in front. I'm still going to make my factor tree with the 50. So that's going to be 2 times 25. 25 breaks down into 5 times 5, and those 5's can't be broken down at all. Now, don't forget, we have this 3 out in front, so I'm going to copy down the 3 first. Now, I see that we have a pair of 5's right here, so we're going to take that 5 out of the radical, and we're going to multiply it by that 3 that was already out in front. This 2 doesn't have any pair, so it stays underneath the radical. Multiplying the 3 times the 5 that are out in the front, we're going to get 15, and we're going to leave that square root of 2 attached to it. So 3 square root of 50 simplifies down into 15 square root of 2. As we take a look at this example, we're doing the square root of 14, so we're going to make our factor tree here. To get 14, we would take 2 times 7. Now, neither one of those can be broken down any further. And if we're thinking about looking for pairs, we can't find any pairs here. So because we're unable to find any pairs, that tells me that we can't break down this radical any further. So the square root of 14 is as simple as that one's going to get. Now for our next one, we've got negative 3 times the square root of 64. We're going to make a factor tree for the 64. That could be 8 times 8. This 8 breaks down into 4 times 2. And the 4 breaks down into 2 times 2. This 8 breaks down into 4 times 2, and this 4 also breaks down into 2 times 2. Now don't forget, we've got this negative 3 hanging out in front, so we're going to leave that there, and then we're going to look for pairs. So right here, I see a pair of 2's, so we're going to take that out. Over here, I see another pair of 2's, so we're going to take that out. And then I also see one more pair of 2's, so I'm going to take that one out. Now I notice that there are no numbers left over that didn't get paired up, so that tells me that I'm no longer going to have a square root in my final answer, but I do need to multiply all of this stuff together. So negative 3 times 2 is negative 6, negative 6 times 2 is negative 12, and negative 12 times 2 more is negative 24. So negative 3 root 64 simplifies down into negative 24. For this next one, we've got the negative square root of 125. Well, 125 breaks down into 5 times 25, and 25 breaks down into 5 times 5. We're looking for pairs of numbers, so I see a pair of 5's, but don't forget about this negative out in front. So when I take the 5 out, I have to put the negative on it. This 5 didn't get paired up with anything, so it's going to stay underneath the radical. So negative square root of 125 simplifies down into negative 5 root 5. And for this last one, we've got 4 square root of 150. So breaking down that 150, I'm going to go 10 times 15. 10 is 2 times 5, and 15 is 3 times 5. Now with this 4 out in front, I'm going to leave the 4 there. I'm looking for pairs of numbers, so I see that we have a pair of 5s. So I'm going to take the 5 out of the radical. Underneath the radical, I don't have a pair for this 2 or this 3, so I'm going to put both of those underneath, and we're supposed to multiply them back together. 4 times 5 is 20. 2 times 3 underneath that radical gives me a root 6. So 4 square root of 150 simplifies down into 20 root 6. That's going to be it for this video. Thanks for watching.